Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is heat transfer, conduction, convection, and radiation. Heat transfer is an essential topic in thermodynamics, playing a crucial role in both nature and technology. It governs everything from the warmth of the sun to the cooling of an engine. Understanding heat transfer helps us grasp fundamental processes in physics, engineering, meteorology, and even human physiology. To begin, let's think about what heat actually is. Heat is a form of energy that flows from a region of higher temperature to a region of lower temperature. The movement of heat is spontaneous and occurs due to the temperature difference between two objects or systems. The greater the temperature difference, the faster the heat transfer. The first method of heat transfer is conduction. This process occurs primarily in solids, where heat energy is passed from one particle to another through direct contact. In metals, conduction is particularly efficient because free electrons help transfer energy rapidly. Imagine holding a metal rod with one end in a flame. Over time, the heat travels through the rod, making the other end warm. This is conduction in action. Materials like copper and aluminum are excellent conductors, whereas materials like wood and plastic are poor conductors, also known as insulators. The second method is convection, which takes place in fluids, both liquids and gases. Unlike conduction, where heat is transferred through direct contact, convection involves the movement of particles within the fluid itself. When a fluid is heated, it expands, becomes less dense, and rises, while cooler fluid moves in to take its place. This creates a continuous circulation known as a convection current. A common example is boiling water. As the water at the bottom of a pot is heated, it rises, allowing cooler water to sink and get heated in turn. This mechanism is responsible for ocean currents, atmospheric winds, and even the transfer of heat in our own bodies through blood circulation. The third method is radiation, which is unique because it does not require a medium to transfer heat. Radiation occurs through electromagnetic waves, primarily infrared waves. This means heat can travel even through the vacuum of space. The most common example of radiation is the heat we receive from the sun. Despite the vast distance between Earth and the sun, solar energy reaches us through radiation. Similarly, when you stand near a fire, you feel warmth without actually touching the flames. This is radiation at work. Dark-colored surfaces tend to absorb more radiation, while lighter surfaces reflect it, which is why people wear light-colored clothes in summer to stay cool. A common example of radiation is feeling warmth from a campfire or the sunday. Even though air is a poor conductor of heat, we can still feel warmth at a distance due to the infrared waves emitted by the hot object. Unlike conduction and convection, which require direct contact or a medium, radiation can transfer energy across empty space. The effectiveness of radiation depends on the surface properties of an object. Dark, rough surfaces absorb and emit more radiation compared to shiny, reflective surfaces, which tend to reflect heat away. Heat transfer through radiation is also crucial in engineering applications. Thermos flasks, for instance, minimize heat loss by incorporating reflective surfaces that reduce radiation. Similarly, satellites and spacecraft use special coatings to regulate their temperature in space, where conduction and convection are absent. These three mechanisms of heat transfer often work together in real-life scenarios. For example, when cooking food on a stove, conduction transfers heat from the burner to the pan, convection circulates heat within the cooking liquid, and radiation from the flame or heating element adds to the process. Engineers and scientists use their understanding of these principles to develop better insulation, energy-efficient appliances, and advanced cooling systems. In many engineering applications, understanding heat transfer is crucial for designing efficient systems. For example, in thermal power plants, heat energy is converted into electricity through conduction in metal pipes, convection in steam turbines, and radiation from hot surfaces. In the automotive industry, car engines use cooling systems that rely on convection to dissipate excess heat, preventing overheating. Even in space exploration, heat transfer principles are vital for designing spacecraft that can withstand extreme temperatures without losing or gaining too much heat. Insulation is another key aspect of managing heat transfer. By controlling conduction, convection, and radiation, insulation materials help maintain desired temperatures in homes, refrigerators, and industrial machinery. For instance, thermos flasks use vacuum insulation to minimize heat loss by conduction and convection, while reflective coatings reduce heat transfer by radiation. Similarly, space suits worn by astronauts are designed with multiple layers to regulate body temperature in the harsh conditions of space. Understanding heat transfer not only enhances our knowledge of physics but also has practical implications in daily life. From cooking and climate control to engineering and space exploration, the principles of conduction, convection, and radiation shape the way we interact with heat energy. As technology advances, new materials and techniques continue to improve the efficiency of heat management, making our lives more comfortable and sustainable. These three heat transfer mechanisms often work together in everyday life. Consider a hot cup of tea. Heat is conducted through the cup to your hands, convection occurs as steam rises, and radiation allows heat to spread into the surrounding air. Engineers and scientists harness these principles in designing insulation materials, heating systems, and even spacecraft to regulate temperatures effectively. Understanding heat transfer is essential not just for physics but also for practical applications in energy efficiency, climate science, and medical technology. It plays a vital role in how we design buildings, cook food, and manage industrial processes. Thank you. That brings us to the end of today's discussion. Keep exploring, keep learning, and stay motivated in your NEET preparation. This is AskPrep, and we will see you in the next video with more interesting concepts in physics. Stay curious and keep working towards your goals.